All right, 2.4, day 3, the final section of 2.4. See an opener there? So please pause the video, finish the opener, and come back to check your answer when done. Here's the answer for g of x that you should have got. X to the fourth minus 5x to the third plus 25x squared minus 55x plus 34. All right, today we're going to kind of build on what we've been doing here. If we're given one complex zero of a function, we can use the fact that zeros come in complex conjugate pairs that we talked about yesterday, along with polynomial long division that we talked about earlier in this chapter, to find our remaining zeros. So here we have an example. Given negative 3i is a 0 of j of x. Find the remaining zeros. Because it's a cubic, we know that there are 3 zeros. Okay, we are only given 1 0, but technically we are given 2 zeros, because since 1 0 is negative 3i, another 0 must be positive 3i. We can use the products of the factors x minus 3i and x plus 3i to get a real factor of the polynomial. So let's do that. By FOIL, we get x squared plus 3ix minus 3ix minus 9i squared. Middle terms cancel out. So we're left with x squared minus 9i squared. Remember that I squared is just negative 1. So this is x squared plus 9. So this means x squared plus 9 is a real factor of our function. Okay? We can now use long division to find our other factor or factors. In this case, only one other factor, but sometimes it's more. So now let's use long division. X cubed divided by x squared is x. Multiplying, subtracting, negative 5x squared divided by x squared is minus 5. Multiplying and subtracting. We should get 0 because we know it's a factor. Okay, so that means now I can write j of x as x squared plus 9 times x minus 5. And that is completely factored form, which means our final answers here are negative 3i, which we have, positive 3i, and then 5. So these are the other remaining zeros. Negative 3i was given to us, so we don't need to write that again. Let's take a look at example 2. Given 2i is a 0, that also means negative 2i is a 0 of f of x. Find the remaining zeros. All right, so we have x minus 2i and x plus 2i. Distributing that, we get x squared. Again, the middle terms will cancel. So we're left with x squared plus 4. So using long division, remember this should be 0 because we know it's a factor. X to the fourth divided by x squared is x squared. Multiplying, subtracting, we get 8x cubed plus 12x squared, and then bring down the 32x and 48. Dividing again, we get 8x. Subtracting, we get 12x squared plus 0 plus 48. And dividing again, we get 12. And of course, we do get 0 at the end. All right, so that means now I can rewrite f of x as x squared plus 4 times x squared plus 8x plus 12. So now I can continue to factor that, or I can use the quadratic formula, whatever you prefer. But why not factor it when we can? That's completely factored form. So the remaining zeros, we were given 2i, so we don't need to write that. Negative 2i, negative 6, negative 2. Number 3. Given 3 plus I is a 0, that also means 3 minus I is a 0. So I have the factors x minus 3 plus I and x minus 3 minus I. So lots of simplifying here. First, I'm just going to distribute that negative sign. Distribute the x to everything. Distribute the negative 3 to everything. And distribute the negative I to everything. And we should notice a couple things here. We should notice those two will cancel themselves out. And we should also notice those two will cancel themselves out. And one more thing, this is just negative, negative 1, so really that's just plus 1. So now I can rewrite this as x squared minus 6x plus 10. So x squared minus 6x plus 10 will go into g of x. X cubed over x squared is x. Subtracting, we get positive 2x squared minus 12x plus 20. Dividing again, we get 2. Multiplying, we should get 0 here, which we do. So finally, I can write g of x as x squared minus 6x plus 10 times x plus 2. That is completely factored form. So find the remaining zeros. 3 plus I was given to us. 3 minus I is new. And we get negative 2 as well. All right, I'd like you to pause the video there and try example 4. You're going to have to combine pieces of problems 2 and 3 to do problem 4. It's going to take you a few minutes, so pause the video, do the best you can, and come back and check it when you're ready. All right, here is the work and answer for number 4. Feel free to pause the video and look it over. And when you're ready to look at number 5, get a graphing calculator ready to go. So example 5, find the complex zeros of the function. Use a calculator and sketch a graph. So there's our function. Let's go ahead and pop that into y1. And I don't know what window to use, so I'm just going to use a regular window for now. It's number 6, zoom standard. That's clearly not a very good window. So I'm going to open that up just by zooming out, which is number 3. And still not a window. So you know what I'm going to do? I'm just going to make my own window here. I'm going to go negative 20 to 20 and negative 100 to 100. And let's see if that's any good. Getting better. Looks like we're going to have to go way further down here on the y minimum. So let's go to negative 300 and see if that's good. Now we're almost there. A little bit further. Let's go to negative 400. Maybe even negative 500. Or even 600. That's good enough. We can see what we need to see. Actually, we can see what we need to see for a long time. All we need to see are the 2 zeros in the graph. Okay? So you can see it crosses the x-axis 2 times. We got to find those 2 axes, the 2 times they cross the axis. So go to second calculate, and number 2 is 0. And just use your cursor. Let's find the one on the right first. Go just to the left of that one, and then go just to the right of that one. And you can see our answer here is 4. So 4, 0 is our first answer. Actually it says 0, so we should write it as x equals 4. Repeat that process, so number 2 again, and now it's time to scroll to the left of the left 0, and then to the right of that. Looks like our answer is negative 7. So that's what we need from the calculator. Now we got everything we need. Why not use synthetic division on these two and make it a lot easier on ourselves? A lot of ways to do this problem right now, but synthetic's probably the easiest. So we should get 0 for this. If we don't, something's wrong. And we did. Keep going. Now let's use negative 7. Again, we should get 0 for this. And we did. So now I can write f of x as x minus 4, x plus 7, and then what's left over here is 1x squared plus 0x plus 9. So we already have the answers from here and here. We just need to get our answers from here. So x squared plus 9 equals 0. X squared equals negative 9. X equals plus or minus root negative 9. So x equals plus or minus 3i. So to finally answer the question here, find the complex zeros. There are 4 of them. X equals 4. X equals negative 7. X equals plus or minus 3i. And that is a wrap on section 2.4.